Hello, my name is Kelsey Livingston. I'm a third-year biomedical engineering major with a focus on biomaterials. Today I'm going to tell you about what Christopher Wanczak, author for Live Science, has to say about the advancements in brain cancer, as well as this cancer's immortality switch. First off, Christopher Wanczak is an accredited author with 4 books publishing relating to advancements in modern medicine, as well as over 100 articles written for Live Science, keeping up to date on a variety of medical research. His column, Bad Medicine, evaluates these research ideas to see what sounds promising and what has a low chance of working within the future. The main focus of Wanczak's brain cancer article is to keep his audience up to date on advancements being made to treat glioblastoma, the most common and dangerous type of brain cancer. To do so, Wanczak keeps focus of researchers Joseph Costello from University of California, San Francisco, and his breakthrough in finding the cure to glioblastoma. What makes this article, as well as the other research that went into it, important in particular is from the increase of attention towards glioblastoma following John McCain's death by it late last month. Before going into the key points of Wanczak's research, I would like to break down the facts of GBM for those who are not familiar with the disease. First off, as stated before, GBM is the most common and most dangerous form of brain cancer. While there has been a decrease in new cases each year, a drop from 18,000 to 16,000 predicted this upcoming year, the likelihood of surviving the disease are still slim. So research teams have been working really hard to discover what causes GBM as well as what can cure it. From this mission, research teams such as Joseph Costello's have made strides in what may be causing cancer. One breakthrough that the team has had finding a relationship between the enzyme GABP beta-1L and an increase in cancer cells. Overall, when the GABP beta-1L enzyme overmodifies the GABP protein, a change then occurs to the brain's protein telomerase. This change involves an overuse of its enzyme called TERT. This change in TERT is huge. What this enzyme does is provide genetic modifications for telomerase that allow the protein to continuously grow without dying and getting replaced. While this does not sound horrible in theory, there is a problem. As the TERT enzyme continues to grow, the telomerase protein keeps going as well. It also continuously gives the protein more room for mutations to occur. This in turn leads to cancerous tumors forming. Now, with this new information, Costello and his research team have realized that past treatment options are not best for treating the TERT mutation. Options such as chemotherapy, surgery, or radiation therapy will not work due to them not specifically targeting the beta-1L enzyme or the TERT mutation alone. So, Costello and his team have decided to point their focus towards CRISPR technology to solve the mutation problem. This method is one where gene codes are extracted from a person, modified using the CRISPR technology, and placed back into the person to have the code reproduced. Up until now, Costello and his team have only tested this method by extracting DNA from humans, modifying the codes, and then placing the new code back into mice instead of humans. So far, there have been no signs of glioblastoma occurring within the mice, and hopefully that it will occur later on with humans. Because of the success so far, Costello and his team are hoping to continue their testing with mice while they try to formulate a code that will only keep the GBAP beta-1L enzyme from mutating the TERT switch. As for now, they are only refocusing on coding the DNA to have the TERT switch completely turned off. From there, Costello will hopefully advance his research from mice to humans. Overall, Wanczak outlines Costello's research team on the research for what they believe can cure glioblastoma brain cancer. The team believes that the GABP beta-1 enzyme influences the TERT switch, which then influences the mutation of the chromosome's telomerase, causing the formation of cancerous brain tumors. Costello's team has been working on extracting individuals' genes, recoding the strand, and injecting it back into the humans. This, in turn, is supposed to stop the continuation of the TERT mutations. In the end, the team believes that this procedure will decrease the cases of glioblastoma into extinction. Thank you for listening, and I hope you have learned from Christopher Wanczak's research.